કેમ છો બધા? So today we will start with circular motion. Okay, so you know the example of circular motion. So you can see the giant wheel. Okay, so here motion is along the periphery. So this motion is called circular motion. So circular motion is another example of two-dimensional motion. So whenever we apply a force to the object, consider a object. So when we apply a force to the object, so object will move along the straight line. So why it follows circular path? Okay, so there should be one force, or you can say there should be one inward force, and because of this inward force, this object follow the circular path. It means, suppose consider this applied force. Okay, so here the inward force should be in this direction, and because of this inward force it follows the circular path. So this inward force, so that is called centripetal force, and because of centripetal force object follow the circular path. Okay, so create circular motion in a body, it must be given some initial velocity, and a force must then act on a body which always directed at right angle to the instantaneous velocity and again towards the center. Okay, so this is circular motion. So you know the many example of circular motion. So let us start discussion. So in the circular motion, so motion is along the circumference. The motion of particle along the circumference of circle is called circular motion, and velocity is always perpendicular to the direction. So this motion is called circular motion. So there are two types of circular motion. One is uniform circular motion and second one is non-uniform circular motion. Okay. So in the uniform circular motion, it is also called UCM and non-UCM. So in case of uniform circular motion, speed of the object remains constant. So in case of particle along the circumference of a circle with constant speed is called uniform circular motion. So example of uniform circular motion, so revolution of moon around the earth. So revolution of moon around the earth. So that is speed is constant. Velocity is constant? No, velocity is not constant, but speed is constant. So in uniform circular motion, speed is constant. While in case of non-uniform motion, speed changes with respect to time. Okay. So motion of the particle along circumference of the circle with variable speed is called non-uniform circular motion. Okay, so motion of giant wheel. So initially speed is 0, then speed increases, after some times it becomes constant, then again speed decreases or it may increases. So here we can apply non-uniform circular motion. Okay, so just like linear motion, in the linear motion, first we have defined position, then displacement, then distance, velocity, acceleration. Okay, so similarly for angular motion or for circular motion, we will define position, velocity, angular displacement, angular acceleration. Okay, so step by step. Okay, but to understand linear motion, that very easy, because in everyday life we are experiencing linear motion. So when we take a ride, okay, so motion is straight line motion. Okay, but in the giant wheel motion is circular motion, so we have less experience of circular motion, so it is somewhat difficult to understand circular motion. Okay, but we have to visualize circular motion. So if you can visualize it, then you can understand it very easily. Okay, so let us start with the first term, so that is position. So position is its position or location with reference to origin. Okay, so in two-dimensional motion we can represent position with the help of position vector. So now we can see initial position A, we can represent it with position vector R1. Okay, after some time position is B and position vector is R2. Okay, so displacement is change in position. Displacement is change in position. It means final position minus initial position. Okay, so that is delta R. Delta R is equal to R2 minus R1. So R2 minus R1. So you can say R2 and R1. So 1 2 2. So 1 2 2. So this represents delta R, or you can say displacement vector delta R. So direction is from A to B. Okay, and magnitude R2 minus R1. So R2 is vector, R1 is vector. So calculate magnitude. So mod of R2 minus R1 is R1 square plus R2 square minus 2 R1 R2 cos theta. R1 square plus R2 square minus 2 R1 R2 cos theta. Okay, in circular motion always R1 is equal to R2 because magnitude of R1 is equal to magnitude of R2 and that is equal to R. So replace. So R1 plus R1, you can say 2R1 minus R1 into R2, 2R square cos theta. So now 2R square constant, 1 minus cos theta. So 1 minus cos, so you can say under root 2R square, 1 minus cos, 2 sine square theta by 2. Okay, so 2 into 2, 4 under root 4, 2 r square, so that is r, and sine square, so that is sine. So 2r sine theta by 2, so that is equal to delta r. So if you know angle theta, if you know radius, you can calculate delta r. Okay, so magnitude 2r sine theta by 2 and position or direction, so that is delta r. Clear? So remember this equation. And distance, so what is distance? So you can consider distance from A to B. So displacement is from A to B. So this is your displacement, and as far as distance is concerned, so distance is path followed by particle. You can say displacement. So displacement is suppose S. So S is equal to R into theta. So D is equal to length of arc AB is equal to R into theta. So S is equal to R into theta. Clear? So particle is rotating in circle of radius r. The distance traversed by it completing half circle. Okay, so traveling along the circle and distance, so that is for half circle. So now we have to find distance. So if it is full circle, then 2 pi r, half circle, so divide by 2. So answer is pi r. An athlete complete one round of circular track of radius 10 meter in 40 seconds. So one round of circular track. You can consider one round of circular track. Okay. So one round, so radius 10 meter and it take 40 seconds. The distance covered by him in 2 minutes and 20 seconds. So in 2 minutes and 20 seconds. So to complete one round, it requires 40 seconds. Okay. So in 2 minutes and 20 seconds, how many rounds he will complete? So n is equal to, total time 2 minutes. So 120 plus 20, 140 divided by 40. So that is equal to 3.5 revolution. Okay, so now distance. So distance d is equal to, so if it completes one revolution, then distance is equal to 2 pi r. So radius r is equal to 10 meter into number of revolution. So that is 3.5 divided by 10. Okay, so answer is 70 into pi. Approximately you can say, so that is 3.1 more. I think somewhere I have made the mistake. 2 pi r. So radius, so distance, so that is 2 pi. Okay, so I can take here pi is equal to 22 by 7. So 7, so that is 5. So 5 into 2, 20. So 5 into 2, 10, 22 into 10, so that is 220 meters. So answer is 220 meters. So answer is 220 meters. Next example, a wheel cover distance of 9.5 kilometer in 2000 revolution. The diameter of wheel, okay, suppose consider wheel. So wheel cover 9.5 kilometer. Okay, so if we consider distance covered, so that is 9.5 kilometer. And number of revolution, so that is 2000. The diameter of the wheel, so find out diameter of the wheel. So total distance cover d is equal to, so distance covered in one revolution, so that is equal to pi d. So distance covered in one revolution multiplied by number of revolution, so that is 2000. Okay, and that is equal to 9.5. So you can say 9.5. So diameter d is equal to 9.5. It should be in meter. So into 10 raised to 3 divided by pi into 2000. Okay, so 1000 cancel. You can say 95. So you can say 10. So now 3.14 into 3. So approximately here you will get 3. Okay, so here you will get 3, or initially you will get 30. So 10, 10 cancel. So directly you will get 3 by 2. So that is 1.5 meter. So diameter is equal to 1.5. So diameter of wheel is equal to 1.5. So now angular displacement. So first we have to define angular position or angular displacement. Okay, so now angular displacement, so you can consider, okay, so in case of linear motion, how we have defined position. So position or location, that is with reference to origin. Okay, so similarly in case of angular motion, so first we have to define reference state. Okay, so suppose this is O is the axis, then from the axis draw a line. So this line is called reference line. So always angle is measured with this reference line. So if we rotate in anti-clockwise direction, then angle theta is positive. If we rotate in clockwise direction, then angle is negative. So if I say plus 30, it means in anti-clockwise direction, minus 30, it means in clockwise direction. Okay, so now initially suppose angle on this reference line, we can say theta is equal to 0, and at another position you can say at point A angle is theta. So angular displacement is theta minus 0, so that is theta. So change in position. So angle turned by body moving on a circle from some reference line is called angular displacement. So this angle turn with reference to reference line, that is called angular displacement. So that is angle theta. So unit, you can say radian or degree. Okay, m0 l0 t0, because there is no dimensional formula relation between pi and degree. So 360 degree is equal to 2 pi. Okay, and angular displacement is axial vector quantity. So you can find out the magnitude. We can either say positive or negative. Okay, but how can we find the direction? Because angular displacement is axial vector. Angular displacement is axial vector. So how can we find direction? Okay, so now you can see with reference line. So you can see this is our reference line. Okay, so now rotate right hand or fingers in the direction of rotation. So when I will rotate in the direction of rotation, this thumb represents direction of angular displacement. direction of angular displacement. So you can see here, so one more relation, you know, S is equal to R theta. So let us see right hand rule. So you can see the plane of rotation, okay, position, center, axis. Okay, so when we rotate in anti-clockwise direction, okay, in anti-clockwise direction, when we rotate in anti-clockwise direction, this thumb represents direction of angular as displacement, direction of angular displacement. So you can see right hand thumb rule. Okay, so actually in upward direction, okay, so what will move in upward direction? So nothing will move in upward direction. So what does it represents? So it represents the sense of rotation. It represents the sense of rotation of the object, and it also represents the plane of rotation of object. It represents the plane of rotation of, so plane of rotation is perpendicular to the direction, okay, and sense of rotation, so that is according to right hand thumb rule. Okay, so now you can see delta theta, so direction of vector. So thus direction of vector indicates plane of rotation and sense of rotation of the particle. So it represents plane of rotation and sense of rotation. Okay, so if we rotate the object in clockwise direction, okay, so now suppose instead of anti-clockwise, now suppose we rotate in clockwise direction, then direction is in downward. Okay, so direction of angular displacement, that is in downward direction. So now you can see clockwise rotation, clockwise rotation. Okay, so displacement, so that is in downward direction according to right hand thumb rule. Okay, this is direction of vector delta theta. The flywheel rotates at constant speed of 3000 rpm. The angle described by the shaft in radian. Okay, so if it completes one revolution, then angle is 2 pi. If it completes 3000 revolution, then what should be the angle? So angle theta is equal to 2 pi into number of revolution, but it should be in second, rps. So divide it by 60. So you will get 50 into 2. So that is 100 pi. So angle is 100 pi. So angle described by the shaft. Clear? So now next is angular velocity. So now you know angular displacement. So at particular time, suppose at position A, angular displacement is theta 1. At position B, angular displacement is theta 2. Okay, then angular velocity is rate of change of displacement. Angular velocity of object in circular motion is defined as time rate of change of its angular displacement. So so change in displacement delta theta, so that is equal to theta 2 minus theta 1. So rate of change of, so you divide it by t2 minus t1. So this is called average angular velocity. If delta t tends to 0, then that is called angular velocity or instantaneous angular velocity, and that is equal to d theta by dt. That is equal to d theta by dt. So now you can see angle traced divided by time taken. So limit delta t tends to delta theta by delta t, d theta by dt. So omega is equal to d theta by dt. And what should be the direction? So direction is along the angular displacement. So according to right hand thumb rule. Okay, so you need radian per second, or you can say degree per second. Dimensional, so t minus 1. So angular velocity is also axial vector along the direction of displacement. Okay, and v is equal to omega cross r. So this we will prove after some time. So scooter is going round a circular road of radius 100 meter at speed 10 meter per second. So v is given, r is given. Angular speed of the scooter. So v is equal to r into omega. So omega is equal to v upon r. So v, so that is 10, r so that is 100. So I can say 0.1 radian per second. 0.1 radian per second. Clear? So answer is 0.1 radian per second. A particle P is moving in a circle of radius A with uniform speed V. So speed of the particle, so that is V. So I can mark speed here with velocity V. C is the center of circle. So C is the center of circle and AB is the diameter. So AB is the diameter. When passing through the B, the angular velocity of point P about A and C, so about C and about A are in ratio. It means find out angular velocity with respect to C and angular velocity with respect to A. So about A and C, the angular velocity about A and angular velocity about C. So V is equal to omega into R. So V is constant for both the case. It means omega is inversely proportional to R. Omega is inversely proportional to R. So for omega A upon omega C, I can write it is equal to RC upon RA. RC. So when C is the center distance, so that is equal to A. RA, when A is center distance, so A plus A, so I can say 2A. So answer is 1 upon 2. So omega A by omega C, so answer is 1:2. The ratio of angular velocity of rotation of minute hand of a clock with angular velocity of rotation of the earth about its own axis. Okay, so angular velocity of minute hand to the angular velocity of earth. So take the ratio. So now angular velocity omega is equal to, so that is equal to 2 pi by time period t. So for one rotation, so that is 2 pi, and time period, so time period for minute hand, so I can say divide it by 60. So one revolution and time period, so that is 60. For earth, again one complete rotation, so I can say 2 pi. So for one complete rotation, time period is 24 hour. So divided by 24 hour, but here unit is minute, so convert it into minute. So 24 into 60. So if we take the ratio, then 24 by 2 pi by 60, 2 pi by 60 cancel. So answer is ratio is 24. Ratio is 24. Done. The length of second hand of watch is 10 mm. What is the change in angular speed of watch after 15 seconds? Suppose 0 second and after 15 seconds. Okay, but angular speed of minute hand, so that is constant. Angular speed is constant, then change in angular speed, so change in angular speed, so that is 0, because omega is constant. If omega is not constant, then time will change. Okay, so time is, so the rate of change of time, that is constant. Okay, so omega is constant, so change in angular speed, so that is 0. So now consider change in velocity. Okay, so change in velocity. So now consider, suppose initially object is at position A. So at A velocity, so that is always perpendicular to the circle. So velocity V1. Okay, so with change in position, velocity changes. So velocity is V2. So change in velocity, so that is delta V. So delta V is equal to V2 minus V1. So delta V is equal to V2 minus V1. Okay, so find out the magnitude. So magnitude is equal to mod of V2 minus V1. Okay, so if you take mod of V2 minus V1, then vector A minus B, so under root S square, so V1 square plus V2 square minus 2 V1 V2 cos theta minus 2 V1 V2 cos theta. So you can calculate it very easily. So now you know the magnitude. Now what should be the direction? So for the direction, follow vector notation. So v2 minus v1. So you can see vector v2. So vector v2 minus v1. So v1. So consider minus v1. So v2 minus v1. So shift this vector. So you will get delta v. You will get delta v. So delta v, so that is towards the center. Delta v, so that is towards the center. So you can see delta v. Okay, so vector v2, vector v1, so minus v1 and resultant, so that is delta v, v2 minus v1, that is inside. Clear? So you can find the direction of delta v. Okay, so for uniform circular motion, okay, so v1 is equal to v2 because there is no change in speed. So v1 is equal to v2 is equal to v. Okay, so I can consider delta v. So v1 v square plus v square, so that is 2v square. Here I can say 1 minus cos theta, 1 minus cos 2 sin square theta by 2. So already we have proved twice v sin theta by 2. So already we have proved this equation. Okay, and what should be the angle phi? Okay, so angle phi, it should be, so if it is theta, so then remaining angle is 180 minus theta, 180 minus theta, and if v1 and v2 both are same, then it should be half angle. So divide it by 2. So phi is equal to 180 minus theta divide by 2. Okay, so if this angle is theta, then remaining angle, so that is 180 minus theta, and v2 and v1 magnitude is same, so angle, so that should be equal division. Okay, so that is 180 minus theta divided by 2, so 90 minus theta by 2. Okay, so now we want to find the relation between omega and v. So v is equal to omega cross r, so that we want to prove now. So consider a circle performing radius r. Okay, so now let us consider linear speed v and angular speed, so that is omega. Okay, so now small displacement, so that is delta theta. Okay, so with small angular displacement delta theta, so this distance covered, so that is delta s. So relation between delta s and delta theta, so delta s is equal to r into delta theta. So differentiate with respect to time. Okay, so delta s by delta t is equal to r delta theta by delta t. Delta t tends to 0, so we can say ds by dt is equal to r d theta by dt. ds by dt is equal to r d theta by dt. So now we know what is ds by dt. So ds by dt is v, d theta by dt is omega. So we can say v is equal to r into omega. V is equal to r into omega. So if we think about the direction, then velocity, so that is velocity is in perpendicular to circle. So direction of velocity r, so v and r both are perpendicular. Okay, so if I will consider the direction of velocity, so this is direction of velocity, this is direction of radius. So velocity, radius. Okay, and angular velocity, so angular velocity, so that is perpendicular, so I can consider this thumb, so that is omega. So v, r and omega, so all are mutually perpendicular. So v, r and omega, v, r and omega, so v, r and omega, so all are mutually perpendicular, so we can represent it in form of vector. So v is equal to r cross omega. V is equal to, sorry, omega cross r. So V is equal to omega cross r. So remember this equation, V is equal to r omega and V is equal to omega cross r. So relation between linear speed and angular speed. Okay, so now consider initial velocity v. Okay, so at this position velocity is always perpendicular to radius. So linear velocity is always perpendicular to radius vector. So you can see perpendicular to radius vector. Okay, but here radius is fixed, velocity is also fixed, so magnitude is same, but the direction, so that is different. So angular velocity is perpendicular to the plane of radius vector, and linear velocity, it means that is plane of perpendicular. Okay, so here the velocity is same, no, velocity changes, but its direction changes, magnitude remains same. So in uniform circular motion, okay, so speed is constant. In USM, magnitude of velocity is constant, but direction is not same. Okay, so you can see the direction. So direction at different point. So you can see slowly. At different position, velocity is always perpendicular. Okay, so magnitude is same, but direction, so direction is different. Clear? So acceleration is rate of change of velocity. So USM, acceleration of motion, because change in direction of velocity. So acceleration is due to change in direction of velocity, not due to magnitude. Okay, so now consider first example. If a particle moves in circle describing equal angle in equal time interval, so delta theta delta t, so delta theta by delta t, that is constant, it means omega is constant, it means speed is constant. So if speed is constant, then velocity vector, so velocity constant, change in magnitude, change in direction, change in both. So if speed is constant, then also velocity changes in direction, direction is different, so that is always perpendicular. Okay, magnitude not constant. Okay, not both will change. Clear? So only direction will change. A boy is whirled in horizontal circle of radius 20 centimeter. It has angular velocity 10 radian per second. So what is linear velocity? So v is equal to r into omega. So v is equal to r into omega. So radius, so that is 20 centimeter. We want meter, so 20 into 10 raised to minus 2, and omega, so that is 10. So 200 into 10 raised to minus 2. So 2 meter per second. So answer is 2 meter per second. So what is the value of linear velocity if omega 3i minus 4j plus 3k and r 5i minus 6a plus 6k? Okay, so we know the relation cross product v is equal to omega cross r. V is equal to omega cross r. So v is equal to I, j and k. V is equal to, actually it is r cross omega. Okay, so 6 omega is 3 minus 4 3. Okay, and r, so r is equal to 5 minus 6 6. So now simplified, so 6 minus 24 plus 18, so that is I, minus 18 minus 15 j plus minus 18 plus 20 k. The answer is minus 6i minus 3j plus 2k. So 6i plus 3j. Okay, so you can reverse it. 6i plus 3j minus 2k. The answer should be, okay, so it should be 6i plus 3j minus 2. So now one more term, so that is time period. So in circular motion, okay, so time required to complete one revolution, time required to complete one revolution. So that is called time period. So in circular motion, time period is defined as time taken by the object to complete one revolution in on circular path. So unit is second. So T1. So time period of second hand or watch, so that is 60 second. For minute hand, 60 minute, and hour hand, so that is 12 hour. So we will use this in example. Okay, frequency. So that is number of revolution completed, number of revolution completed in 1 second, number of revolution completed in 1 second. So frequency is defined as number of revolution completed by the object on its circular path in unit time, so in 1 second. So okay, so unit hertz or second inverse, so T minus 1. So relation between time period and frequency. So relation between time period and frequency. So frequency. So number of revolution completed in 1 second. Okay. So in 1 second, number of revolution completed. So if t is equal to time, if time is equal to t, then what should be the number of revolution? So that is time t is equal to 1 upon n. T is equal to 1 upon n. For to complete one circle, okay, how much time is required? So T is equal to 1 upon n. So relation between angular velocity, frequency and time period. So angular velocity omega, so omega is equal to delta theta upon delta t. So when particle completes one circle, so delta theta, so that is equal to 2 pi. Okay, and time required to complete one circle, so that is t. So omega is equal to 2 pi by t. Omega is equal to 2 pi by t, and 1 upon t is equal to n. So you can say 2 pi n. So omega is equal to 2 pi n or 2 pi by t, and time period t is equal to 1 upon n. Angular acceleration. So we have discussed angular velocity. So now rate of change of velocity, rate of change of angular velocity, so that is angular acceleration. Okay, so rate of change of angular velocity is called angular acceleration. So alpha is equal to, so first we can say delta omega by delta t. When delta t tends to 0, so d omega by dt, so that is d square theta by dt square. So that is alpha, angular rate of change of angular velocity. So alpha is equal to d square theta by dt square or d omega by dt. Okay, so what should be the direction of alpha? So direction of alpha should be in the direction of omega or in the reverse direction. So first understand displacement, velocity and acceleration. It means angular displacement, angular velocity and angular acceleration. Try to visualize. Suppose consider now. Okay, so angular displacement. So now you can see, so this is angular displacement. So change in angle is angular displacement. Now angular velocity, so that is speed. Okay, so now angular velocity in first case, angular velocity in second case, so in speed is higher, so that is called angular velocity. Now angular acceleration is when you start the fan, initial speed is less but speed increases, so it means angular acceleration increases. Okay, so acceleration is positive, it means rotate the speed at faster rate, then speed increases. Okay, so when you switch off, speed decreases. Okay, so angular velocity, so that is it may be in upward or it may be in downward, that depends on rotation. Okay, but acceleration, so it may be upward or it may be downward, so that depends on if speed increasing or speed decreasing. Okay, I will show you the demo. So now clear? So displacement means rotation, speed means rate of change of displacement, acceleration means rate of change of speed, how fast speed is changing. Clear? So now unit radian per second square, dimension t minus 2. So now consider direction. So direction of angular velocity omega and angular acceleration alpha. Okay, so omega is increasing with time, alpha is in direction of omega. So omega is increasing. It means speed is increasing with time. So now consider. So speed, you can see speed increasing. Okay, so omega should be in upward direction. Omega should be in upward direction. So if omega is in upward direction, naturally rate of change of speed, so alpha should be in upward direction. So alpha acceleration, so that is also in upward direction. Clear? But if speed decreasing, so omega decreasing with time, then alpha is in opposite direction of omega. So now you can see the speed decreasing. Okay, so angular velocity, so that is in upward direction. Okay, because rotation, that is again same anti-clockwise, so angular velocity should be in upward direction, but speed decreasing, so alpha should be in downward direction. Okay, because omega 2 is less than omega 1, so acceleration is negative, so direction should be negative direction. Okay, so it is in negative direction. And relations already we have derived for velocity. Similarly for acceleration, linear acceleration A is equal to alpha cross r. A is equal to alpha cross r. And for uniform circular motion, omega is constant. So d omega by dt, so that is 0. It means alpha is equal to 0. It means acceleration is equal to 0. It means angular velocity is constant. So uniform circular motion, angular acceleration is 0. So tangential acceleration also equals to 0. So tangential acceleration, so that part we will discuss later. In non-uniform circular motion, alpha is not 0. It means speed either increasing or speed decreasing. Alpha is not 0. It means speed is not constant. A body is revolving with uniform speed in a circle of radius, the angular acceleration. So with uniform speed, so speed is constant, so acceleration should be, 0 because uniform speed, so acceleration is 0. The linear acceleration of car is 10 meter per second square. If the wheels of car have diameter of 1 meter, the angular acceleration, so linear acceleration A is equal to alpha into r. The angular acceleration alpha is equal to A upon r. A is equal to, so that is 10. R is equal to, so diameter is 1 meter, radius 0.5, so it should be 20 radian per second square. So 20 radian per second square. Angular speed of motor increases from 6000 rpm to 12,000 rpm in 10 seconds. Omega 2, omega 1. So what is the angular acceleration? So alpha is equal to omega 2 minus omega 1 upon delta t. So omega 2, so that is 1200 minus omega 1, so that is 600 divided by time. So time is 10 second. So will it work? So this is revolution per minute and we want per second. So divide it by 60. Again it will work. So unit is revolution per minute and omega should be in radian per second. So convert revolution into radian. So multiply it by 2 pi. So now 600 divided by 600. So answer is 2 pi radian per second square. So 2 pi radian per second square. So next concept, so that is centripetal acceleration. So here I will introduce concept only. Okay, so in the next lecture we will discuss in detail centripetal force, centrifugal force and example based on this. Okay, so I am just introducing the concept so we can solve few example. So now centripetal acceleration. So acceleration is delta v by delta t. So already we have discussed the initial velocity v1. Okay, suppose final velocity v2. So V1 and V2. So delta V. So delta V. So you can say V2. Okay, and V1. So delta V is V2 minus V1. So already we have proved it. Okay, so minus V1. So minus V1. So draw the circle, and this is, you can change the color. So this is what? So this is delta V. So here acceleration, so that is in the direction of delta V. It means acceleration is in inward direction. Okay, so now here delta t is suppose finite. Instead of this, suppose delta t tends to 0. It means shift position from this point to here, here and here and again nearer. Then acceleration is in towards the center. So this delta V represents acceleration, and acceleration that is towards the center. So that is called centripetal acceleration. So delta T tends to 0 and acceleration that is towards the center, it is called centripetal acceleration. So instantaneous centripetal acceleration. And acceleration, so always act on the object along the radius towards the center of circle. Okay, acceleration is equal to omega square r. Omega is equal to v upon r, so v square by r, or omega is equal to 2 pi by t, so 4 pi square n square r, or omega 2 pi by t or 2 pi n, then 4 pi square n square. So you can use any equation. Okay, and direction of centripetal is, so that is always same as delta V, so that is always towards the center. Okay, so later on we will discuss in detail. Okay, let us solve few examples. So if a cycle wheel of radius 4 meter complete one revolution in 2 seconds, so time period t is equal to 2 seconds, then acceleration of cycle. So acceleration is equal to, so omega square, so that is 4 pi square t square into r. So 4 pi square upon t, so t is equal to 2 square, so that is 4 into radius r, so radius r is equal to 4, so 4 cancel, so answer is 4 pi square. So acceleration is 4 pi square meter per second square. A stone is tied to one end of the spring 50 centimeter long is whirled in horizontal circle. So stone whirled in horizontal circle with radius is equal to 50 centimeter. If the stone make 10 revolution in 20 seconds, so 10 revolution in 20 seconds, what is the magnitude of acceleration? So here time is given, so we can consider 4 pi square upon t square into r. So radius is given, but time period is given? No, directly it is not given. So stone make 10 revolution in 20 seconds. So 10 revolution 20 seconds, for one revolution, so t is equal to 20 by 10, so that is equal to 2. So 4 pi square divided by 4 into 50. We want answer in terms of centimeters, so keep it as it is. So now 4 cancel. So pi square, it means 3.14 whole square. So approximately around 10. So 10 into 50, so that is 500. So answer should be 493. It should be less than that. So 493 instead of 500. Clear? So you can take approximation. So two cars going round the curve with speed, one at 90 km per hour and other at 15 km per hour. Each car experience same acceleration. So acceleration is equal to v square upon r. Okay, so for both the car acceleration is constant. It means r is proportional to v square. The radius of curvature are in the ratio. So find out RA upon RB. So that is equal to VA upon VB whole square. So VA, so that is 90, VB, so that is 15. So 90 by 15 whole square. So I can say 36. The answer is 30. Clear? So in the next lecture, now we will discuss centripetal force, centrifugal force, and that is very, very interesting. So thank you very much.